So previous years, you guys dealt with counting number exponents, raising something to the first, second, third, fourth, whatever. Last year, we talked about the zero exponent. This year, we've already talked about fraction exponents. So the last group left to talk about when we're dealing with exponents are negative ones. Okay? And just to prove to you how we evaluate a negative exponent, consider this, or it could be written like that too. Well, we could expand it out. 3 squared is the same as 3 times 3 over 3 to the 5th, which is 3 times 3 times 3 times 3 times 3. Can I do anything with some 3's? To make this easier to work with? Yeah. Yeah. Those reduce to 1. So what's that pair? But then there's no other pairs of 3's that I can reduce. So I end up with 1 times 1 up top, and 3 times 3 times 3 on the bottom, which is the same as 3 to the third. And I'm going to leave it like that. Yes, it does equal 1 over 27, but I want to show you how it relates to negative exponents, because there's another way we could look at 3 to the second divide 3 to the fifth. Well, when we divide powers that have the same base, the base stays the same, and we subtract the exponents. And what is 2 subtract 5? Negative 3. So 3 squared divide 3 to the 5th could look like this, or could look like this. These are equivalent. Except I'm not used to evaluating negative exponents, but if I can write it like this, I know how to do it. So, following that pattern, how do you think you would write this using a negative exponent? If 3 to the negative third equals 1 over 3 to the positive third, then 4 to the negative second equals 1 over 4 to the positive second. And like if we did, what do you think this would be as a positive exponent?
1 over 3 to the positive.
1 over 2 to the positive 4. And I'd rather see this because I know how to do these. You guys know how to do positive exponents. So we could say that 3 to the negative third is 1 over 3 to the positive third, which is 1 over 27. 4 to the negative second is equal to 1 over 4 to the positive second, which is 1 over 16. 2 to the negative fourth equals 1 over 2 to the positive fourth, which again equals 1 over 16. Right? So, like I said, we can see from above that 3 to the negative third is the same as 1 over 3 to the positive third. So here's how we evaluate negative exponents or deal with them. First of all, we're going to write the base, the number, the big number, as a fraction. And you can write any number as a fraction by tossing it over 1. But I want to change it to a positive exponent. So what do? we just flip the base, which is the same as 1 to the n, which is just 1 over x to the n. So it actually deals with reciprocals. Whenever you have a negative exponent, you take the reciprocal of the base, and that allows you to make a positive exponent. So let's look at it now. So the first one, this would be the same as 3 over 1 to the negative second. All I did was change the 3 to a fraction. And now what do I do to make it a positive exponent? What do I do to the base? And what is 1 over 3 to the positive second? Well, it's the same as 1 squared over 3 squared, which is 1 over 9. Good. The reason why you should write it like fractions is because what happens if the base is a fraction? Well, we follow the same pattern. How do I write this with a positive exponent? 4 over 3. And then this is just the same as doing 4 to the third over 3 to the third, which would give me a final answer of 4 over 7. Be careful when there's negative numbers as the base, especially if it has parentheses. Because remember, this is the same as negative 2 over 1 to the negative 4. I haven't changed it yet. To change it to a positive exponent of 4, I flip the base, take the reciprocal of the base. And remember, this is the same as 1 to the 4th, which is, what's 1 to the 4th? No. 1. Because you're multiplying 4 ones by themselves. What is negative 2 in parentheses to the 4th? The parentheses matter because it means negative 2 times negative 2 times negative 2 times negative 2, which is positive 16. What happens when we combine what we did last lesson with what we're doing now? Negative fraction exponents. Well, first thing we want to do is we want to get rid of the negative. So remember, this is the same as 25 over 1 to the negative 1/2. You don't have to write that step. You can jump right to the next step. How do I write this using a positive exponent? 1 over 25. Remember, don't flip this. You only flip the base. The positive 1/2. And how did we deal with fraction exponents again? What did we do to them? We made them into, oh, really? I know it's Monday morning, but come on. Really? What did I make it into in order to find the answer? Well, a radical, right? So The base goes in here. The exponent is 1, so that's the same as raising it to the 1, which I don't have to write. And the root is square root in this case. So that means we've got to find the square root of 1 over 25, which remember is the same as the square root of 1 over the square root of 25, which is 1 over 5. Try the next example, A. Work with a partner if you want to. Very similar. Except now we've got a number besides 1. Okay. Anybody want to walk me through it? Come on. Yeah.
The parentheses and then 8 over 1. Then you switch it to 1 over 8. And then.
Sorry. Yeah.
Positive.
Yeah.
And then after that, 2 through 8. Or
Cube root.
8 over 1.
Why don't you flip it? Cube root 1 over 8.
And then squared.
And then we're going to have to square the whole thing. Excellent. So the cube root of 1 over 8.
2.
1 over 2, and I still have to square it.
1 over.
Nice. Excellent.
One question.
Yeah.
Wait. Actually, never mind. If I don't have to split it,
What's that? Why do you have to square it?
because it's like,
Because of this 2 here.
um,
Remember when there's a numerator besides 1 with fraction exponents? You got to square it, or whatever the exponent is. Okay, so this next one, let's walk through this one together. What would you do here first? Flip it to make the exponent positive. I've got a fraction exponent, so I got to go to radical form. What's it going to look like? Square root 16 over 9. And then I'm going to take that whole thing to the third. So square root of 16 over the square root of 9. And then I still have to cube it. 64 over 27. Excellent. Good. There we go. 10. So you see, some of them can get a little complex. But now you are familiar with how to evaluate any type of exponent. Okay? And I'm actually not going to do the last example. We're not going to do this. This last example is just really about how do you use a calculator to do fraction and negative exponents, but I'm not going to worry about that. Okay? So we're going to leave that one alone. I'm more concerned about what we did, the stuff that we did in this lesson already.